Hello, continuing our work in the tangents of circles, we're going to work through this problem here. Find the equation of the tangents to this circle through the point 13 minus 1. Well, something immediately jumps out at me if I'm reading this as an exam question. Tangents, plural. There's a little s there that tells us an awful lot. We're going to get the equation of two lines that are tangents to this circle and go through this point. Well, what do I immediately want to do? As always, I'm going to want to draw a sketch. So I'm going to write down the equation of my circle and my point so that I know what parts of my x and y axis I have to have drawn in for my sketch. So this is an equation that I recognize as being in the form x minus h to be squared plus y minus k to be squared is equal to r squared, with a center at h and k, and r squared is going to be equal to 8, therefore r is going to be equal to root 8 is equal to 2 root 2. If we break that down into 4 multiplied by 2, so we end up with 2 root 2, which for the purposes of sketching, if I put that in my calculator, ends up being very approximately equal to 2.8, so that I can draw a bit of a rough sketch using it. And my center is at h and k, so I have minus h and minus k in my formula. This is part of why it's so important that we go to our log tables and write this down underneath the equation that we've been given. I can see that the 8 is r squared, and I can see that h is going to be 5, not minus 5, because the equation I'm working from has minus in front of the h. So this minus 5 here means that h is at 5, and my k, the y value of my center, is going to be at 3, not minus 3. So we write down the equation we are using to figure out our center and our radius. If we don't do that, the chances of making a mistake are very high. Now I have enough information to draw in, I need my point. I know that the point 13 minus 1 is a point that I need to draw on my axis. So I know that my center of my circle is at 5, 3, and I know that my radius is about 2.8, so about 3, or a little less than 3, and I know that I have to have the point x is 13, y is minus 1. So my y values are going to have to go from minus 1 up to about 5, or maybe 6, and my x values will go from 0 up to 13 or 14. So that's what I need for my sketch. So let's draw that in. This does not need to be wildly accurate, but we just want to try and get it good enough that we have a clear picture of what it is we're aiming. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I'll go up to 14. 1, 2, 3, 4, 5, 6, I'll say 7, and minus 1, minus 2. I'm going to put in a minus 1 here as well. These sketches tell us how we are going to approach the problem. Otherwise, the chances of making a mistake in something that is so geometrically based is extremely high, and there is no reason not to do this. It takes only a moment, particularly if you have squared paper, as you will have in the exam. This is as fast as we are able to do it. So I know that my center is at 5, 3, so 5, 3. Approximately there is my center. And I know that my radius is 2.8, so it's going to be just above the x-axis that comes in. So I draw in a very rough circle somewhere around like that. And I know that my point that I'm dealing with is 13 minus 1. So I go over to 13 and minus 1, somewhere approximately here. And I know that I am looking for the tangents that go through this point and are tangents to my circle here. So let's try and draw them in. I'm going to end up with something approximately like so. So I now know that I'm looking for my two equations. I will label them. I'll call this upper one L1 and this lower one L2. And what do I know about these? Well, I know that I have my center is going to be at my 5, 3. And I know that the distance from this point out to each of these lines is going to be root 8. It's going to be the same. And these are the perpendicular. These lines are perpendicular to these dashed lines that I have come out here. So the perpendicular distance from L1 and L2 is going to be root 8. And I know that it goes through the point 13 minus 1. And I know my perpendicular distance is from the point 5, 3. I now have all of the tools that I need in order to solve this problem, because I know that I'm dealing with lines, so I'm going to write down the equation of my line formula. So for L1 and L2, what do I know? Well, I know that 13 minus 1 is a point on the line. So that's an element of L1 and L2. But I do not know the slope of my line. So I don't know the slope of L1 or L2. But I could use my line equation as normal, y minus y1, because I know that a tangent is a line. So I can use that fact along with the fact that I know that I have my point on my line is x1, y1. That's true for both L1 and L2, but I don't know this. I don't know the slope m. So let's sub in and see what we can do. Minus 1 is equal to m on x minus 13. So y plus 1 is equal to mx minus 13m. Now, what would I do after this point? Well, as so often happens in this chapter, I am going to be dealing with the perpendicular distance from the center out to my line. We keep using this tool over and over again in the chapter, and this is just another example of it. This is the other piece of information we know, so it's what we're going to use. Well, if I want the equation of this line, which is the equation of both L1 and L2, and I want to use the perpendicular distance formula, I'm going to have to rearrange it into a form that works better for that. So if I rearrange my equation of L1 and L2, I will end up with mx minus y minus 13m minus 1 is equal to 0. We all know how to rearrange our equations. And now this is in the form ax plus by plus c is equal to 0, which is the equation I need for my perpendicular distance. And how do I know I need to use perpendicular distance? Because I drew my diagram and I can see that's the information I've got to work with. So I know that my perpendicular distance from L1 or L2 to 5, 3, the center of my circle, is going to be equal to the radius, which is equal to the square root of 8. So I'm going to write down my perpendicular distance formula, which is given to us in our log tables. And I know that at A is equal to m, B is equal to -1, and C is everything that is not a coefficient of x and y. It's all the constant stuff relative to x and y. So that's going to be -13m -1, both of those things, because both of them don't involve x's and y's. So they're both constants relative to x and y. So I can now sub in, and I have my x1 and y1 are my 5 and 3, the center of my circle. So subbing in, I get this, and simplifying down, I am going to get square root of 8 is equal to absolute value of -8m -4 all over the square root of m squared plus 1. Now I recognize that I have an absolute value problem. I'm going to isolate the absolute value and then square both sides. Now, rearranging and squaring both sides, I have the square of 2 square roots here. There's an important point to mention. I'm going to square both sides and instead of getting plus or minus what's going on here, because I will have to square to get rid of the square roots anyway. So there's no advantage in doing the plus or minus version of getting rid of an absolute value here. So I end up with 8 on m squared plus 1 is equal to -8m -4 to be squared. When I multiply that out, I recognize that I am now just solving a quadratic in m to get my two values of m for the two different slopes of my lines. So I'm going to work that down now, just solving a normal quadratic. Rearranging and factorizing, recognizing that I have a common factor of 8 across here, I simplified my quadratic by dividing both sides by 8, and then I was easily able to factorize it into two brackets. If you didn't spot that, using the -b formula will give you a perfectly accurate answer. I now have my two values for the slope of L1 and L2, and now I'm going to use my equation of my line formula along with the point 13 minus 1, and subbing in I will get my two equations for my lines. Subbing in and rearranging, I get my equation for L2 and L1. How do I know which one is which? Because from my diagram I know that at L1 has a steeper negative slope than L2 as I have drawn them, and a slope of -1/7 is more gradual than a slope of -1. So that is how it is we approach this situation where we know a point and we know that we have two tangents to our circle. So you can see the centrality of this sketch. Once I have been able to figure out how to draw this sketch, I know all of the information that I need in order to figure this out. I know the perpendicular distance is the same for both of these lines. It's both equal to the radius, and I can use that information to figure out what the slope must be, and then